Good afternoon, class. Our lesson for today is about points, lines, and planes. So I have already uploaded this PDF file in our Canvas last week, and I hope that you have already read this one. This time I'll be sharing to you some important points about this lesson. Let's begin with the objectives. The objectives of this lesson are state undefined terms, state postulates about points, lines, planes, and real numbers. Therefore, at the end of this class, you will be able to, or you should be able to, understand by stating undefined terms and also stating some of the postulates relating to points, lines, planes, and real numbers. So let's begin with the undefined term. So as I have told you last meeting, there are really terms such as undefined terms in plane and solid geometry, in geometry. And long time ago, these terms are already called undefined terms. Not because we don't know what are this or they don't have definition, but we cannot establish a clear or we cannot prove them in mathematical terms. So let's start in this section by stating undefined terms. So what are these undefined terms? These undefined terms provide a starting point for developing an axiomatic system. So in our deductive reasoning last time or in our previous module, you have encountered undefined terms as happy, pleasant, and the other one. So they are undefined terms. But really, again, there are undefined terms in geometry. So let's begin with the following undefined terms. So we have here a point. So that is one of the undefined terms in geometry. Point. Another one is line. And the next one is plane. Before we discuss that further, let's have this portion. It says, have you ever looked closely at the screen on a television set? The surface is composed of thousands of small dots called pixels that glow when hit by an electron beam. That's why when we buy a camera or a cell phone, we are so particular about or of the pixels. It should be 13 MP or beyond that, because the lesser the pixels, the lower the value of your or the quality of your pictures. That's why we or you should be particular of the number of pixels that your camera can handle. So that's called pixels, small dots, because you can just draw or create a figure using pixels. Can you imagine cross-stitching? That's the concept of pixel. So, diba, square lang sila. Then you put a color in this square, another color in that square. But when you finish doing all the pattern, you can see that it creates a figure. So that's the concept of pixel. When viewed from a distance, the individual dots blend together, forming the picture. Each dot serves as a model for a point, one of the simplest geometric figures as we study or that we study. So a point is the simplest geometric figure. Let's proceed to how they are defined. So a set, so these are the four undefined terms in geometry. However, some authors just presented three, but most of the mathematicians use the four. We will begin with a set. So a set is a collection or group of objects. That's a set. Next is a point, and it can be thought as an object that determines a position but that has no dimension, length, width, or height. So dimension, length, width, or height, the point did not possess that attribute. So therefore, it is defined as an object that determines position but has no dimension. So we can symbolize a point. How to write a point? It can be a dot with the label of a capital letter. So when you create a figure or or locate a point, be sure that you use capital letter to name it. The next undefined term in geometry is a line. This is a set of points in one-dimensional straight figure that extends in opposite directions without ending. Okay? Line. That is one undefined term. Lahi po tong ray. Lahi po tong another term for those with directions, but without directions we can extend it without ending, and we call that a line. So how to denote a line? You use this as a symbol for a line. So capital letters of the endpoints and this line with arrows in both ends to no, to no, okay, to symbolize a line. So when appropriate, using lowercase such as L. So if you are not confident in using this, or you don't like to have many letters or symbols in your presentation, you can use lowercase letters such as this. It should be written in this way. So finally, we have a plane. So what is a plane? It is a set of points on a flat surface, such as the face of a blackboard, having two dimensions and extending without boundary. We often represent a plane, as shown in figure 1.1, and symbolize plain script letters such as P. So notice this one. This one is a plane. And this one is a line BC, and this is point A. So definition, space and geometric figure. So what is a space? A space, the set of all points is called space. So that is a technical term to represent the set of all points in mathematics. Space, particularly in geometry. Any set of points, lines, or planes in space is called a geometric figure. So a set of points, lines, or planes in space is called a geometric figure. Can you imagine your notebook? Kanang notebook nga dots ang nakabutang instead of lines or graphing paper. Okay? If you treat each intersection as a point, so that notebook, a one-page notebook, that one page of the notebook is called space because it is represented by the set of all points. But when you draw something there connecting some of the points, you call that geometric figure. So using points, line, or planes, you can create a geometric figure. Now let's proceed with objective number 2, state postulates about points, lines, planes, and real numbers. So we can think of geometry as the study of properties of geometric figures. Some of these properties must be assumed in the form of postulates. Did you remember what is a postulate? Okay, so I will not tell you again what is a postulate. Check your notes and be able to remember what is a postulate. It's in our previous lesson. So given any two distinct points in space, there is exactly one line that passes through them. If you are curious, you can draw or you can put two dots in your paper and try to make a line which passes both of the points. and see how many lines you can create, because postulate 1.1, it says that there is only or exactly one line that passes through two distinct points in space. Intuitively, postulate 1.1 tells us that we can draw one and only one straight line through two different points. So that is postulate 1.1. Remember that, because as you prove next sessions, you need the postulates to assist you in proving. Postulate 1.2, given any three distinct points in space not on the same line, there is exactly one plane that passes through them, and that plane can be a triangle. Okay, three distinct points in space not on the same line. Of course, because we can only create line with two distinct points. So if you are connecting two of the points given that three distinct points, then you can only have one plane. So that those are postulates 1.1 and 1.2. Example here in figure 1.2, we call these points as coplanar because they line in the same plane. So if the points are in the same plane, we call them coplanar. Okay, notice that A, B, and C are not on the same line here in point A. So shows the plane containing the 3 points A, B, and C. These points are coplanar, but they are not linear. Okay, so if 3 points such as D, E, F in figure B 1.2b lie on the same line, we can see that more than one plane can obtain them. So if the points that you can see in a plane can be drawn a line or can form a straight line, therefore there are two planes that can represent those points. Okay, kani siya o kaning nasa ibaba o kani siya. And let's proceed to the next student activity. On a piece of paper, place 5 points. So you do this and upload your output or send it to me via messenger. So on a piece of paper, place 5 points. Label them A, B, C, D, and E as in the drawing here shown at the right. Next, fold the paper so that point E is on the fold. Open the paper slightly and think of the paper as two planes meeting at the fold. Answer the following questions. There are maybe more than one correct answer. So name 3 coplanar points, name 3 non-coplanar points, and 3 name a point in both planes. So that is a student activity that you need to do today and submit it in the uploading section of this module. Let's proceed with postulate 1.3. The line determined by any two distinct points in a plane is also contained in the plane. Yeah, so if you can determine a line from any two distinct points in a plane, that is also contained in the plane. Okay, a line determined by any two distinct points in a plane is also contained in the plane. Yeah, because you get it from the plane. From postulate 1.3, we see that when we draw lines between points in a given plane, we always remain in the plane. The next postulate guarantees that there are more points in space than those found in any given plane. Postulate 1.4 states that no plane contains all points in space. Correct. From the previous postulate, space contains at least 4 points that are not all in the same plane. So the next postulate has numerous applications in algebra. And in fact, in some writers or authors, this is the very first postulate in geometry, the Ruler Postulate. So there is a one-to-one correspondence between the set of all points on a line and the set of all real numbers. Diba sa atong ruler, kung imo nang i-check, it represents also the real number system. Okay, so that is the ruler postulate. Again, recall postulate 1.1, postulate 1.2, postulate 1.3, postulate 1.4. No plane contains all points in space. And postulate 1.5, the ruler postulate. And it says that there is a one-to-one correspondence between the set of all points on a line and the set of all real numbers. So if we draw a line, select a point on it and call it origin, mark off equal units in both directions and label these points with integers, the result is called number line. So notice in figure 1.3 that is an example of a number line. The number corresponding to a given point on the line is called coordinate of the point. So the number corresponding to a given point on the line is called the coordinate of the point. And when we identify a point with a given real number, we are plotting the point associated with the number. So, inganiin nyo pag-introduce ang number line sa inyong mga students. So, you create a line and then divide it or place a point at the middle, and then on the left side are numbers less than 0, on the right side numbers greater than 0. And the numbers representing each point, we call them coordinate. And when we first say a number and then plot it, so we are plotting the point associated with the number. Mo nang na instruction, plot the points, blah blah blah. So example, plot the points associated with the real numbers 1/2, -3/4, square root of 2, and 2.5 on a number line. They are all in the number line. So tanang numbers na dara sa number line, you can plot them just as in figure 1.4. Let's proceed. Because there are infinitely many real numbers, there are infinitely many points on any given line. This conclusion is actually a theorem, a statement that can be proved. When proving certain theorems in geometry, we will use some of the following postulate from algebra. So, from postulate 1.1 to postulate 1.4, we don't have names of the postulates, but in postulate 1.5, we already call it the ruler postulate. Now, let's proceed with these algebraic postulates. We have first is, let's emphasize the note first. Algebraic laws and geometric postulates are both statements accepted as true without needing to be proved. Diba? Katong laws and postulates. Ang theorem lang ang dapat na i-prove. For this reason, the words law and postulate when referring to algebraic laws are used interchangeably throughout this book. So, as we go along the discussion in this class, we can be using postulate and law interchangeably. Remember, they are facts or concepts in geometry that don't need proof. So let's begin with postulate 1.6, the reflexive law. Any quantity is equal to itself. Yes, that is the reflexive law. The symmetric law is if x and y are any two quantities and x equals y, then y equals x. That is symmetric. And postulate 1.8, the transitive law. If x, y, and z are any three quantities with x equals y and y equals z, therefore x equals z. Again, reflexive. Any quantity is equal to itself. The symmetric, if x and y are any two quantities and x equals y, then y equals x. Ang transitive law is if x, y, and z are any three quantities with x equals y and y equals z, then x equals z. So it follows that if x equals y niya, ang y equal man po ni z niya, ang y kay equal man to ni x, so meaning si x po equal ni z, so inanaon siya. That is transitive law. And then we will proceed with postulate Postulate 1.9, the Addition Subtraction Law. If W, X, Y, and Z are any four quantities with W equals X and Y equals Z, then W plus Y equals X plus Z, and W minus Y equals X minus Z, because the condition was or is W equals X and Y equals Z. So this is addition subtraction law. You have met this in your junior high school, maybe grade 8, grade 7. So the addition subtraction law states that if equal quantities are added to or subtracted from equal quantities, the results are also equal, because you are adding the same value and subtracting the same value from the same quantities. Therefore, the result is also equal. For postulate 1.10, we have the multiplication division law. So given four quantities W, X, Y, and Z, with W equals X and Y equals Z, then the multiplication of W and Y is equal to X multiplied by Z, and the division of W and Y is equal to the division of Z, provided, however, that in your division there is no zero as the denominator. Okay, because any number divided by zero is not defined. So we don't have a number. We cannot define a number divided by a zero. So remember the multiplication division law. It has a restriction that if Y and Z are equal to 0, that is not defined in mathematics. So the multiplication division law states that if equal quantities are multiplied or divided by equal quantities, division by 0 excluded, the results are also equal. So nana mo reflexive, symmetric, transitive, addition subtraction law, multiplication division law, and now let's proceed to postulate 1.11, the substitution law. So if you have X and Y, which are any two quantities with X equals Y, then X can be substituted for Y in any expression containing Y. So magamit ni nato in algebraic and geometric proving, substitution law. Therefore, kung si X, yung value Y, so tanang value ni X or tanang variable na X sa imong equation, since equal siya ni Y, pwede nimo ma-replace with the value of Y. Okay, that is the substitution law. For postulate 1.12, we have the distributive law. So if X, Y, and Z are any three quantities, then distributive law, X quantity Y plus Z is equal to X distributed to Y and X times plus X times Z. So X times Y plus X times Z, you distribute it. So those are the or the algebraic laws that we can use also in geometry. So postulates 1.6 to 1.12 are used extensively when solving algebraic equations. That is how you identify each step in your solution using this law. Or in your junior high school years and senior high school years, we call them properties. Okay, so in your college days, you call them postulates and sometimes laws, but they can be interchangeably used throughout our discussion. So what are those? Reflexive law, transitive law, symmetric law, addition subtraction law, multiplication division law, the distributive law, and the previous one is the substitution law. So I hope you can remember them from now until mag-teach na mo. Hindi na ninyo ni kalimtan. Okay? So for your exercises in this module, you have practice exercise 1, and please answer all these numbers encircled with a red ink. So practice exercise 1, approximate the coordinates of points A, B, C, and D as shown on the following number line. The answers are approximations, so your answers made differ slightly. Magkapareha gani mong duha, sure na ko nagsabot mo because looking at this, lahi-lahi dapat mo pananaw ani kaning point C lahi man ni, ang point D lahi pod siya, ang B lahi, ang A pod, or except sa A and B pwede mo parehas og answer because it's really in a point. However, your approximations for the points C and D should vary at least slightly. Okay, so you need to answer again these items with us encircled with the red ink. How many lines can be drawn between two distinct points? You also provide us or provide me with the postulate. Number 3, if distinct points A and B are in plane P and point C is on the line determined by A and B, what can be said about C relative to P? So those or this question can be answered with a postulate in mind. So take note. Then in exercises, the instructions are here 5 to 8. A, B, and C are distinct points. L and M are lines. And P is a plane. Name the postulate illustrated by each statement. So you can go over the postulates we have discussed a while ago. And also this one, approximate the coordinates points A, B, C, and D on the given number lines, and complete each statement using the specified postulate. So in our discussion with the postulates above, we don't have examples. We only use variables. But in this exercise, you need to, instead of using a variable, you use a real number to represent the law given in each item. So you need to answer all of them since they are all encircled with the red ink. And number 18 to 22, you answer them by true or false. And then number 23, this is what I say, provide the law given in this portion. So katong subtraction and addition, multiplication and division, klaro man na siya dira. So just supply the needed algebraic laws to give reasons to how you solve the equation. Okay, so that's all for this lesson. I'll be uploading another lesson later, that is lesson 1.3 for module 1. Thank you very much and God bless you always.